Okay, everyone, let's finish this work with discussion on hyperbolas. Now, again, literal meaning in Greek means excess, and probably in the English language, we also hear about the word hyperbole, which means excessively, talking excessively about something. So that would be a hyperbole. So hyperbola meaning excess, but again, it has no bearing on the graph of this. Let's take a look at the specifics and the equation of the hyperbolas. First of all, going back to our double nap cone, this is how a hyperbola could be generated. When the flat surface crosses both naps of the cone, and again, the impression that it leaves outside the cone, we have two branches. Each of these is called a branch of that hyperbola. Okay. And here is the actual formal definition. A hyperbola is the collection of all points in a plane. The difference, remember for the ellipse we had the sum of distances. For the hyperbola we have the difference of whose distances from two fixed points called the foci is constant. The difference is constant. Okay. So first of all, on the left, you're looking at the general graph of some hyperbola. Every hyperbola has a transverse axis, and in the case of a hyperbola, we also have what we call the conjugate axis. With the ellipse, the transverse axis was the major axis, and the minor axis was perpendicular to the major axis running through the center. Well, kind of similar to this one. For hyperbola, you have two axes. Transverse axis runs through the vertices, and the conjugate axis is perpendicular to transverse, running through the center. Now, over on the right side here, we have labeled them using the familiar letters. So suppose P is a point on one branch of the hyperbola, and these are the focal points, the foci. Okay. And by the way, the reflexive property of a hyperbola, very interesting. Let's say an incoming ray hits the surface, the outer surface of the hyperbola. That ray will reflect right through here in the focus. An incoming ray from the bottom hitting the surface of this branch of the hyperbola will reflect at the other focal point. And again, these reflexive properties are used extensively in design of telescopes and lenses, so they play a key role in the field of optics. All right. Now, we can go through, but again, the proof is in the book. Okay, it's in the book. I don't want to take up too much time for the recording time, that is, to show you something that you can explore on your own. Based on the definition of a hyperbola, you can actually come up with the equation of the hyperbola. The differences, by the way, on this graph, I didn't describe it. The difference between here and here is going to be fixed. Okay, difference between two points, right? Two fixed points is constant here. C, like before, C is distance from center, is measured from center to focus. Center to focus. And like the ellipse, A is the distance from center to a vertex. But this is just to clarify the definition of the ellipse. Okay, and that's what that is. Now, the center of this hyperbola, that's the center, is going to be here. Okay. And you have your two foci. Now, let's take a look at this other hyperbola that I have here for you. And for this one now, so we have the two branches, and this one is a little more in tune with what we need to do. So let me give you the equation for the horizontal transverse axis horizontal hyperbola. The equation is x minus h squared divided by a squared minus y minus k squared divided by b squared is equal to 1. Remember, for the ellipse, the minus was a plus. If you change that plus to minus, then the conic section becomes a hyperbola. And again, this is the one whose transverse axis, TA, is horizontal. Now, because subtraction is not commutative, then we need another equation that goes like this. It goes y minus k squared over a squared minus x minus h squared over b squared is equal to 1. And this one is for the one where transverse axis is vertical. So we really do need to have two distinct, two distinct equations for the hyperbola. Okay. And notice, by the way, that the denominator switched here. B squared, the denominator of y in the first one was b squared. The denominator of the second one is a squared. All right. So there we have those two. Now, the role A, B, C play again, I already mentioned. C is distance from center to a focal point. And what is A? A is distance from center to a vertex. This is A. And B is a distance from the center to the endpoint here of the conjugate axis, to one endpoint of the conjugate axis. Okay. And you don't see it on this drawing, but with an example, I'll show you where B is. Every hyperbola has, except the degenerate case, every hyperbola has a pair of asymptotes. These are the lines that go through the center of the hyperbola, and the branches may not touch nor cross them. Okay, and the equation of them for the one that's centered at 0, 0 is easy to do. It's y equal mx, right? Because b is 0 plus b, but through the center, b is 0. And m is the slope of a line, right? Which is the ratio of rise to run. That's going to be a over bx. For this other asymptote, it's going to be negative a over bx. But again, we don't need to memorize these formulas. I get all this information from the graph of the hyperbola. Okay, so let's actually, let's begin and take a look at an example. Oh, before we do, just one point about the bottom equation, the one that I'm showing you here. This equation would give you hyperbolas that have vertical transverse axis. There you go. See that? Vertical transverse axis. All right. Let's take a look at an example now. In my first example, let's say we want to find the equation of a hyperbola. Find an equation, and of course we always graph these in the end or in the beginning. Start it in the beginning and finish it in the end. So let's say the center is going to be at 0, 0, and one focus is at 0, negative 6, and a vertex would be at 0, 4. Okay, now based on this information, I can actually graph just some basic points here, some rough sketch. 0, negative 6, so 1, 2, 3, 4, 5, 6 is going to be here. That's 0, negative 6. And vertex 0, 4, 1, 2, 3, 4. Let me extend this. Hold on, let me do this with a clean coordinate system. Okay, this looks much better than my hand-drawn coordinate system. Okay, center at 0, 0 is here. Focus is at 0, negative 6. 1, 2, 3, 4, 5, negative 6 would be here. That's one focal point, right? Negative 6. And the vertex is at 0, 4, 1, 2, 3, 4. That's one vertex. Now, the fact that vertex is on the y-axis, right? That tells me the hyperbola, the branches are going to go open up like this, right? And by symmetry, the other one is at negative 4. Now, how wide or how narrow the branches are, correct? That's what we want to answer next. But one thing I know, because I know the transverse axis, the line that runs through the vertices right here, that's transverse axis, is going to be vertical. And for vertical transverse axis, the equation starts with y. I have y minus k squared over a squared plus, or I'm sorry, minus, otherwise plus makes it an ellipse. X minus h squared over b squared is equal to 1. All right, and let's plug in what we know so far. The center is at 0, 0, so this is going to become y squared over a squared minus x squared over b squared is equal to 1, because hk is 0, 0. Correct? Now, one thing, this is important that I forgot. The relationship between a, b, c here, we're going to need this. This time c squared is a squared plus b squared. Right? For the ellipse, remember, it was a squared minus b squared. For the hyperbola, it turns out to be a squared plus b squared. So I'm going to need that relationship here. I know c squared is a squared plus b squared. And what is c distance from center to focus? This is what c is, right? Center to focus, that distance is c, right? C squared is going to be 36. That's negative 6 squared. Equal a squared. A is the distance from center to a vertex. So this is a, right? A is this distance. That's a. A is 4. 4 squared, 16 plus b squared. Therefore, b squared is 20. Right? 36 minus 16. And we can now write the equation of this hyperbola is y squared over 16 minus x squared over 20. Again, don't square those numbers again twice. And that is the equation of the hyperbola. All right, now to graph these more accurately, here's how we're going to graph them. Once we have b squared, we can find b, right? B is plus minus square root of 20, which is plus minus root 4 times 5, and that is plus minus 2 rad 5. Okay, and whatever that number is without the calculator is 2 and change, right? That's what 5 is. So this whole thing is about 4.5-ish, something like that. So 2 root 5. So here's how I'm actually going to graph this hyperbola now. In order to graph the hyperbola, we need to construct what we call a fundamental rectangle. Okay, fundamental rectangle. The fundamental rectangle is just something that's going to help us construct the asymptotes. And then once we know the asymptotes, what they look like, and then I can draw the branches very accurately. So let's see how we construct this fundamental rectangle. To start with, you look at the denominator of y squared, 16. Square root of 16 is 4. You go up 4, down 4. Up 4, down 4. And that's also where the vertices are, right? And then you look at the denominator of x, or x squared, 20. Square root of that is 2 root 5. So you're going to go now to the right and left from the center, 2 root 5. Again, root 5, I'm thinking root 5 is about 2.2-ish, something like that, 2.2, 2.3. It's closer to 2.2. Okay, so 2 times that, that's about 4.4-ish. What matters is this right here. Whatever that is, it's going to be slightly bigger than A. And this is where B is, correct? B is distance from center to that point. And that is what the conjugate axis is now. The conjugate axis is perpendicular to transverse axis. Now, once we have this B, which is 2 root 5, at this point, we're going to construct a rectangle, which they call fundamental rectangle. So I'm going to go parallel to the x-axis, running through 4, negative 4, parallel to the y-axis, running through 2 root 5 and negative 2 root 5. And there is my rectangle. You see that? And then we draw the diagonals of this rectangle. These are the asymptotes. And we can find our equations very easily. In fact, before I crowd this, let's find the slope of these lines. This is going to be the rise, which is 4. And of course, here's your run, which is 2 root 5, correct? So the slope's going to be rise over the run. And that's 2 over root 5, which we can rationalize as 2 root 5 over 5. And that is the slope. The equation of a line that runs through the origin. This is going to have the first asymptote. Its equation is going to be, let me do this. There we go. I'm going to use the lower part of that line because I'm going to need the upper part for the branches. So the equation of that asymptote is going to be y equal to 2 root 5 over 5 mx. There you go. That's the equation of that asymptote. The equation of this asymptote is almost the same except the negative slope. Oh, and that's m, that's x, sorry. M is the slope. X. And there I have the equation of the asymptotes. Now, the branches. Once I have the fundamental rectangle, then I know how wide these branches are going to be. See that? Try to make them so the branches approach the asymptote without touch nor crossing them. And there you have an accurate representation of this hyperbola. All right, so we have the equation. It says find the equation. The answer to the equation is that. And you have the graph as well, along with the asymptotes. All right. Hopefully you follow that one. Let's take a look at another example. This next example, suppose now I want to find the equation of the hyperbola who has foci at plus minus 5, 0 and a vertex on 3, 0. Okay, and again, let me bring my coordinate system first. All right, let's try to do this one. And again, we're trying to find the equation of a hyperbola and we will graph it also. Now, the foci are at 5, so that's 1, 2, 3, 4, 5 on the right. That's 1. And remember, the focal points, the foci, lie in front of the vertex. The fact that foci are located on the x-axis, that tells me that this is going to be a horizontal hyperbola, right? Vertex is at 3, so here's 3. And at this point, I know this would be negative 3. This is what I know so far. I have a horizontal hyperbola. I'm going to go with the equation x minus h squared over a squared minus y minus k squared over b squared equals 1. Good. So we pin down the equation. Now the specifics. Distance from center to a vertex. That's a, right? A is 3. The center is going to be at 0, 0. Center, because halfway between the two vertices is the center, 0, 0. Center is going to be 0, 0. So if h is 0, that numerator becomes just x squared, and a is 3. Square that, you get 9 minus k is 0, so the second fraction's numerator is y squared. And b squared, well, we need to find b. How do we get it? C squared is a squared plus b squared. C is the distance from center to a focal point. That's 5 squared. Equal to a squared plus b squared. So from this, we get 25 minus 9 is b squared, or b squared is 16. That's the denominator of y, and there is the equation. See, that wasn't bad again. And we can actually graph it and show these on the graph. So here's how I'm going to graph this now. Square root of 9 along the x-axis. So I go right 3, left 3. And then square root of 16 along the y-axis. So we're going to go up 4, down 4. 1, 2, 3, 4. And down 4. 1, 2, 3, 4. Down 4. And then we're going to draw the fundamental rectangle parallel to the x-axis and parallel to the x-axis. There you go. And then parallel to the y-axis, it has to go through the vertex. And there you got it. And remember, I set, let me see, 4, but I didn't go high enough. There you go, sorry. Up here, there you go, that's 4. Good. And that's this portion. Now, once I have the fundamental rectangle, let's actually do the asymptotes, because it's much easier visually, yet it's not too distracting. I can draw these. And remember, we are looking for a horizontal hyperbola. So that's going to help me. I can immediately find the equation of these asymptotes. Again, the slope is rise, 4, run is 3. So it's going to be 4/3 x, because it runs through the center, the b part, mx plus b is 0. This other equation is 1 for y equal negative 4/3 x, the other asymptote. Cool. And then all I need to do is go from the center of the box out to the edge of the box, looking for a horizontal hyperbola. So I go to the right and I go to the left, and then I can graph these. There's one branch, and here's the other branch. See that? Just make them approach the asymptotes without touch nor crossing them. And that is the graph of the hyperbola with all the key points labeled. Okay. And there you have this one. Let's take a look at another example here. In this next example, suppose I'm going to stay with center 0, 0, and then later we'll look at a couple examples for off center, off 0, 0. So for this one, let's say my equation is 4x squared negative y squared equals 16. And for this, we want to find the coordinates of the center. We want to find the transverse axis, the vertices, and foci, the whole 9 yards, right? Everything that you want. How about the asymptotes also? And of course, we'll graph it as well. Now, the equation is not in quite standard form, because remember, there has to be a 1 on this side. So what do I need to do? Well, I'm going to divide everything by 16. Whatever this number is, to create a 1 on the right side. So on the left, I'm going to get x squared over 4 negative y squared over 16 equals 1. Because the equation starts with x squared, I know that the hyperbola is going to be horizontal, right? Transverse axis will be horizontal. So I'm going to do that. The transverse axis is going to be what's the center at 0, 0, right? Yep. And the reason, because you can see h and k are 0. So center is going to be at 0, 0. If center is at 0, 0, transverse axis is the x-axis, whose equation is y equals 0, right? Okay, so we got those. Now, what else do I need? vertices, foci, asymptotes. Well, let's try to graph this thing. So I'm going to bring my coordinate system again. And there you go. Now here's my coordinate system. The center is at 0, 0. So I need, remember, first I need to do my fundamental rectangle. So I'm going to go square root of 4. I'm going to go to the right 2, left 2 along the x-axis. Then square root of 16 is 4. I'm going to go up 4 and down 4. 1, 2, 3, 4. And that will outline my fundamental rectangle. I'll draw a horizontal parallel to the x-axis, and then parallel to the y going through those two. Okay. And there's my fundamental rectangle. And then I'm gonna draw the diagonal. Okay, the diagonal. Here's one, there's the other. And it's much easier to get the equation of the asymptotes without having anything else. Once you have the fundamental rectangle, pretty much you have the equation of the asymptotes. So this one is going to be y equal, rise is 4, run is 2. 4 halves x, or simply 2x. The other one is y equal negative 2x. Same, except the slope's negative. So we got the asymptotes. We got that part done. So far, not bad. We got the center, we got the transverse axis, and the asymptote. Vertices and foci. Okay. Now, once I have the fundamental rectangle, I'm going to go from the center. And remember, the equation starts with x squared. So this is going to be a horizontal, right? It's not going to be vertical. The horizontal, again, that means transverse axis is horizontal. So the branch is open to the sides. I'm going to go out to the edge of the box on the right side and draw the branch. So here's one branch, and then go to the other edge of the box on the left and draw the other branch that runs asymptotically towards the asymptote. All right, and there you have the graph of this of this hyperbola. Now, the distance from center to vertex, that's what A is. A is 2, right? So the vertices are at plus minus 2 and 0, which you can break it into 2 points, 2, 0, the other point negative 2, 0. And the foci are going to be in front, right? In front of that hyperbola, right in here. How do we find the foci? Well, we need to find C. C squared is A squared plus B squared. That means A squared is 4, B squared 16, right? I'm looking at the denominators. And remember, do not square them twice. They're already, we see them in their squared form. So C squared is 20, therefore C would be plus or minus 2 root 5. Correct? That's square root of 20, because 20 is 4 times 5. Square root of 4 is 2. That's how you get 2 root 5. And perfect. We got the coordinates of this one, for example. The coordinates is going to be 2 root 5 comma 0. The other one is going to be negative 2 root 5 comma 0. Those are the coordinates of the foci. So the foci are going to be 2 root 5 comma 0. I'm going to go plus minus. Again, you could break this into 2 points. There you have, I found the vertices. I just want to make sure I answered all of the questions. We got the vertices, we got the foci, the asymptotes we found, and yeah, pretty much that's a complete analysis of that hyperbola. Now, let's take a look at ones that are off center. Let's do a couple of these. The ones that are not centered at 0, 0. The general form is x minus h squared over a squared minus y minus k squared over b squared equal 1. I gave you those earlier too, right? See right up here. There. So we have them already. So you could reference this portion of the lecture for the equations. This is just one of the two. Let's take a look at one that uses this one. So in this example, let's say again we want to find an equation of a hyperbola. This time I'm going to let the center be not 0, 0. See, it's 4, negative 1. One focal point will be 7, negative 1, and a vertex of 6, negative 1. Okay. Now I have the equation already here, but let me actually bring my coordinate system up. All right, so here's my coordinate system, x, y. Let's plot these points. The first point is 4, negative 1. 1, 2, 3, 4, negative 1 would be a point right about here, right? That's going to be the center, right? That is the center of this hyperbola. The next point is one focal point, which is at 7, negative 1. So let's see, this was 4, 7, 5, 6, 5, 6, 7 would be this one. This one, right? That's 7. And 7, negative 1. So that's one focal point. Remember, the focus is in front or ahead. In front of the vertex, so the vertex is going to be behind it. Therefore, this is a parabola, or I'm sorry, a hyperbola that opens to the sides with a horizontal transverse axis. And the vertex is at 6, negative 1. So it's right in here. And there we have that one. So we got those key points here. Let's see. I need to draw my, first my equation. Because this is a horizontal hyperbola, the equation is going to be x minus h. I have it up here. Let me not rewrite it again. This is going to be the equation. So in that equation, the center is at 4, negative 1. I'm just going to plug in those numbers now. Therefore, it's going to be x minus 4 squared over a squared minus y plus 1 squared, that's minus 1, over b squared is equal to 1. Now let's see if we can do something here. The distance from center to vertex, which is from 4 to 6, that is what a is. Therefore, a is 2. Okay. A is 2, so a squared is 4. B we don't know yet, but we know the distance from center to a focus. That is what C is. C is 3, right? As you go from 4 to 7, that's a distance of 3 units. Therefore, C squared is 9, and we can say now C squared is the sum of squares of the other two, so that's 9 is equal 4 plus b squared. Thus, b squared is 5. All right, perfect. So we actually have the equation at this point, don't we? It's x minus 4 squared divided by a squared, which is 4 minus y minus 1, which is plus 1 squared, divided by b squared is 5 equals 1. And this is the equation of this hyperbola. Now let's graph it. In order to graph it, I need to, let me see also from here, b is plus minus root 5. Okay, I'm going to need that when I do my fundamental rectangle. In fact, let's do our fundamental rectangle here. So from the center, I go square root of 4, which is 2 to the right, right 2, left 2. Here's left 2 and here's right 2. Those are actually the vertices, right? And then square root of 5. Again, square root of 5 is about 2.2, right? So I'm going to go up and down 2.2 units from the center. That's going to be 1. 2.2 is roughly about here. And 2.2 below it puts me at 2.2 below is right here. Okay, perfect. Now I can draw my fundamental rectangle. They're horizontal, and this would be horizontal to the x-axis. Then you do the vertical running through the vertices. And there I have that one. Too many dotted points. There you have it. And then draw the diagonals. And again, once I have the diagonals, then I can actually find the asymptotes, right? Those are the easiest time because it's not so crowded. There's not so much clutter in my graph. Let's see, how do I find the equation now? Well, because now we no longer, the line doesn't run through the origin, right? So I'm going to use point slope form of a line, mx minus x1. The ones that are not centered at 0, 0, this is how we find the asymptotes. Now, to use this equation, I need a point, right? And I need the slope. Well, the point, use the center for your point. The center is at 4, -1. So it's going to be y minus -1 equals slope x minus 4. Now, how do I find the slope? The slope from the center to here and to the corner of the box. It's going to be rise over run. The rise is this much, right? That's the rise, which is b. B is the rise here. That's square root of 5. Correct? That is b. The run, as you can see, a is the run. And a is 2. So it's going to be root 5 over 2. Rise over run. Good. And there you have it. I can write the equation as y plus 1 equals square root of 5 over 2 x minus 4. That would be the equation. If you want, you can solve for y and get it in slope intercept form. I'm going to leave it like that. Now this is for the one that's up here. So this one is y plus 1 equal root 5 over 2 x minus 4. The other one, which is this one, will be almost the same as y plus 1 because it's going to run through the center. So it has the same coordinates as the previous one for the x and y. The only difference is the slope's negative now, negative root 5 over 2 x minus 4. And there we have the equation of the asymptotes. Now I'm actually going to graph my hyperbola, sorry. So for this now, because remember for horizontal, we know the branch is going to go to the sides, right? So I'm going to start from the center of the box, go out to the edge of the box, and draw one branch. And then we go from center to the edge of the box, the other edge, and draw this one. And now I have the graph of my hyperbola, and again, all the key points are labeled on the graph. This is going to be V, and the vertices were given. One of them was given. We can find the other one. All right. We wanted to find the equation, and we did. So I think very good on this one also. Let's take a look at one last example. Okay. This next example. Let's say for this one, again, we want to find the whole 9 yards. We want to find the center We want to find the transverse axis, the vertices, what else? Foci, and the asymptotes. What else? Oh, and of course, we're going to graph it. So all those details. Now the equation, I'm not going to do an equation that's in the standard HK form. I'm going to do one that's in polynomial form. -1 equals 0. All right. Now, in order to do this, I need to get the equation in standard HK form. So I'm going to group my x's together and plus group my y's together. And the number, I'm going to move to the other side. We don't need it. So I got 4 terms on the left, 1 term on the right side. Now the coefficient in front of squared must be a 1. So I'm going to factor a negative. Factor the negative from y squared and to negative 2y. So those become positive. Now we're going to add, and remember we always add half of the coefficient on squared squared. Half of the coefficient on the squared term, that's 1, the coefficient is 1, and then you square it. That's going to make it 1/2 squared. Let's see, oh, half of the coefficient on x, sorry, is 2. -2. Half of that squared, now it's 1. So I'm going to add and go plus 1 in parentheses. And same thing for the other one, half of that coefficient, except this one is positive. Half of 2 squared is going to be 1. So I'm going to add 1 also. Okay, now let's see to the other side. I added 1 in parentheses. I'm going to add 1 here. And there's nothing outside parentheses that distributes to 1. So it's truly 1 that was added on the left side. Now, I also added 1 in parentheses with the y, but notice that negative on the outside distributes, makes it -1. So I'm going to subtract 1 on the other side actually to keep the balance. And once we do, we got a pair of opposites that add to 0. And the equation now is going to be x minus 1 squared minus y plus 1 squared is equal to 1. Okay, now that is the equation. Right there, that's the equation. But here's how I'm going to write it. Okay, this is going to help me graph it appropriately. I'm going to show both of these, the binomials, over 1, -y plus 1 squared over 1 equal 1. Because remember, the standard form has a squared b squared in the denominator. So I need to see those explicitly, and I'm looking at them now. So this one is going to be a squared, this is going to be b squared, they're equal. C squared is the sum of those two. 1 plus 1 is 2. Therefore, C is plus minus √2. True? Now, because we have the HK form, so let's go and answer those questions we wanted to answer. The center is going to be at 1, -1. Right? H is 1. K is -1 because it's y minus k. That's y minus -1. I rewrote y plus 1 using double negative. And that is what k is. You see that? Again, it's always opposite of what it seems to be in parentheses. If it's a plus 1 in parentheses, k is opposite of that, -1. If it's -1 in parentheses, h is opposite of that, which is 1. Good, so we got the center. What else? Oh, let's go ahead and graph this, and we answer everything else from the graph. Let me again bring my coordinate system first. And here's my coordinate system. Now the center of this one is at 1, -1. So here's 1, -1. That's where the center is. Okay, and then to graph it, we go square root of 1 in the denominator of x. Remember, with x, you go to the right and left. So I'm going to go right one, left one. Square root of b squared, that goes with y. So I'm going to go up one, down one. Here's up one and down one. And then we're going to draw the box because a and b are equal. The fundamental rectangle actually is going to be a fundamental square, right? And there it is. Next, I'm going to draw the diagonal. That's on 1. And the other diagonal goes like so. There we have that. Perfect. Now, here's 1, here's -1. Okay, we're looking for a horizontal because the equation starts with x and then followed by minus y squared. At this point, let's find the asymptotes because it's easy to do to find the asymptotes. The asymptotes, I'm going to go y minus y1 equal m times x minus x1. And we need a point which we're going to use the center as our point. Remember, this is the point slope form of a line. So it goes y minus y1, which is -1, equal m x minus x1. That's y plus 1 equal m. Now, what is the slope of this line, by the way? Again, the slope is a rise, and this is the run, correct? Rise is from here to here, 1 unit, right? A rise of 1, and the run is also 1. Perfect, so the slope's 1, x minus 1, and 1x minus 1 is just x minus 1. So the equation is y. We can leave it like this, or here, this way I can, so many ways we can do this. Let me in fact do this. I'm going to go plus minus 1. So the one that I have up here, this is going to be y plus 1 equal x minus 1. The one below is y plus 1 equal negative x minus 1. And true, I know you can simplify them, and if you like, you could, like in here, y is equal to x, subtract 1 from both sides. That's the slope-intercept form. You could do that. Okay, we got the asymptotes done. And let's graph it. Horizontal transverse axis. Oh, speaking of transverse axis, TA. The transverse axis is going to be, because we have sideways, transverse axis is going to be parallel to x axis. And if you want, the equation of it is going to be y equal -1. And it's this one right here. You see that? That. All right. And what else? What else? Oh, the actual graph. I'm going to go from center to the right, the edge of the box, and draw my first branch. And then center to the edge of the box on the left, and draw the other branch. And there we have it. And that'll be a decent graph. And just to make sure I answered all the questions, center, we have center. We also have transverse axis. Yes, we have the vertices. Nope. Let me write those. What are the vertices? The vertices, one is here, the other one's here, right? So let's do those. The vertices are going to be at, we're going to start at 1, the center, right? At 1, and then we went to the right and left one, and the height is -1. Correct? So that's, those are the coordinates of the vertices. And if you like, you can write it as 1 plus 1 is 2 -1. That's one of them. The other one, 1 minus 1, is 0 -1. This one, oops, sorry, this is -1. So 0, -1 is this one, and 2, -1 is the one on the right side. We got the vertices down. What else did we want? Foci, asymptotes. Oh, we don't have the foci. All right. Remember, the focus is going to be in front of the vertex. So it's going to be here, and the other one's going to be right about here somewhere. Let's find those. That means we need to find C. So let me write it for foci. We know C squared is A squared plus B squared. And we know A squared from the equation up here. We know A squared and B squared are equal to each other, each one. So that's going to be 1 plus 1 and 2. C is plus minus root 2. I think yeah, I was going to say we did that earlier, and we did. That's fine. Did it twice. Okay, so the foci, now what are the coordinates of foci? Well, again, because they start from the center and go to the right, square root of 2. So once you're at center, your x is already at 1, correct? So it's going to be 1, and then we're going to go plus minus, and that means right, left, square root of 2 units, and the height doesn't change. The height is at -1, right? -1 unit below the x-axis. And those are both coordinates, or you can write it as 1 plus root 2 -1, that's 1. The other focal point is going to be 1 minus root 2 and -1. And that will give you both foci, the coordinates of each of them. And I think that's all we wanted to do in this one, correct? Yes. Well, perfect. So we are done with this section. Sorry this went a little longer than I anticipated, but again, it's for a good cause, so sure you don't mind it. We did plenty of examples, didn't we? So with that, we are done with this chapter. In fact, our last of the conic section was hyperbolas, and that's what we did. So we are done with the lecture, and again, as always, thank you for watching and hope to have you in another video. Take care, everyone, and cheers.